Hello science fans. Today we are going on a shocking journey to understand a powerful force of nature, lightning. Have you ever watched a big storm and seen a bright flash of light zigzag across the sky? That is lightning, and it is a fascinating display of electricity at work. Think of it like a giant spark. Storm clouds are very busy places. Inside them, tiny bits of ice and water droplets bump and rub against each other as they are tossed around by strong winds. This constant rubbing and bumping creates static electricity, just like when you rub a balloon on your hair and it stands up. It's science. This constant motion inside the storm cloud separates the electrical charges. The lighter, positively charged particles get pushed up to the top of the cloud. The heavier, negatively charged particles sink down to the bottom of the cloud. This creates a giant separation, with a positive charge at the top and a negative charge at the bottom. Nature loves balance, so it always tries to even out these opposite charges. The air between these charged areas usually acts as an insulator, meaning it stops electricity from flowing. But when the charge difference becomes too great, it's more than the air can handle. When the electrical charge builds up enough, it needs to be released. This release is what we see as a brilliant flash of lightning. The electricity creates a super hot path or channel through the air to connect the opposite charges and neutralize them. It's a quick and powerful way for the storm to find its balance again. This process is happening constantly during a big thunderstorm, which is why we can see many flashes of lightning over a short period. It's an amazing and powerful natural event, all starting with tiny particles bumping around inside a cloud. So, the next time you see a storm brewing, you can imagine what is happening high up in the clouds. Picture all those little ice crystals and water drops dancing around, creating positive and negative zones. This separation of charge is the secret ingredient for the spectacular light show that's about to begin. It is a perfect example of physics happening on a grand scale, right above our heads. The energy that is built up has to go somewhere, and that's when we get to witness the incredible power of lightning. Science is all around us. Not all lightning is the same. Scientists have observed many different types, but we can talk about the three main kinds you might see. The most common type of lightning is called intracloud lightning. This happens entirely inside a single storm cloud. It is a flash that jumps between the positive charges at the top of the cloud and the negative charges at the bottom. These are the flashes that often light up the whole cloud, making it look like a giant lantern in the night sky. Most lightning, more than any other kind, is actually this type. Another type is cloud-to-ground lightning, which is probably the type you think of most. This is when the powerful electrical discharge travels all the way from the storm cloud down to the Earth's surface. This kind of lightning is very dangerous because it can strike the ground, trees, buildings, or anything else standing on the surface. We will talk more about how this type works in a little bit, because it has a very interesting journey. It is the second most common type of lightning, and it is the one we need to be most careful about during a storm. The third type is a little more unusual, and it is called upward lightning. This kind of lightning starts on the ground and travels up to the cloud. It usually begins from a very tall object, like a skyscraper, a radio tower, or a tall mountain. This does not happen on its own. It is almost always triggered by another lightning flash nearby. A separate flash, either inside a cloud or from a cloud to the ground, can suddenly change the electric field in the area. This change can cause a liter of electricity to shoot upwards from the tall object to connect with the storm cloud above. So we have lightning that stays in the cloud, lightning that goes down to the ground, and lightning that goes up from the ground. Each one is a result of the same basic principle nature, trying to balance out positive and negative charges. The path the lightning takes just depends on where the biggest differences in charge are located. Whether it is lighting up a cloud from within, or striking a path to the ground, lightning is always a powerful reminder of the electrical energy that builds up in our atmosphere during a storm. Let's zoom in on that cloud-to-ground lightning. How does it actually make the trip from the sky to the earth? It's a fascinating two-part process. It all starts with something called a step leader. This is an invisible channel of negative charge that steps down from the bottom of the cloud. It doesn't come down in one smooth line. Instead, it moves in short, quick steps, each about 50 meters long. It zigzags its way downward, looking for a path of least resistance to the ground. It is trying to find the easiest way to connect with the ground. As this negatively charged step leader gets closer to the ground, it affects the electrical field of the earth below it. The strong negative charge in the leader pushes away negative charges on the ground and pulls positive charges up. These positive charges start to reach up from the ground towards the descending leader. These are called upward streamers. They can rise from anything on the ground, like trees, buildings, and even people. They are reaching up, trying to connect with the leader coming down from the cloud. It's like they are trying to shake hands. The big moment happens when one of these upward streamers meets the downward moving step leader. The connection is made. This completes the circuit between the cloud and the ground. The instant they connect, a massive surge of electrical current flows rapidly up the channel that the leader created. This is what we see as the bright, brilliant flash of lightning. This part is called the return stroke. It moves from the ground up to the cloud, but it happens so incredibly fast that our eyes see it as a single flash coming down. This return stroke is what does all the work. It is incredibly hot, hotter than the surface of the sun. It heats the air around it in an instant, and it is what carries the massive amount of electricity that can be so destructive. Sometimes, after the first return stroke, more leaders can come down the same path, causing more return strokes. This is why lightning sometimes appears to flicker or strobe. It is actually multiple strokes happening in the exact same place, one after another. Isn't that electrifying? Now, let's talk about lightning's noisy partner, thunder. Have you ever wondered why you hear a loud rumble or crash after a flash of lightning? It's all because of the incredible heat of the return stroke. The lightning channel heats the air around it to about 30,000 degrees Celsius. That is about 5 times hotter than the surface of the sun. When air gets heated that quickly, it expands explosively. It is like a tiny, long explosion happening all along the lightning's path. This explosion creates a powerful shock wave that travels through the air. That shock wave is what we hear as thunder. The sound wave travels much, much slower than the light from the lightning flash. Light is so fast that we see the flash almost instantly. Sound, however, takes about 5 seconds to travel 1 mile, or about 3 seconds to travel 1 kilometer. This is why there is a delay between seeing the lightning and hearing the thunder. You can even use this to estimate how far away a storm is. Just count the seconds between the flash and the bang, and divide by 5 to get the distance in miles. Did you know there are different flavors of cloud-to-ground lightning? Most flashes are negative lightning, which transfers negative charge to the ground and often flickers. But about 5 to 10% are positive lightning. These are much more powerful, coming from the positive top of the cloud. They can be up to 10 times stronger than negative flashes, and usually appear as one single, massive stroke. These are the flashes responsible for the famous bolt from the blue, where lightning can strike miles away from the storm, seemingly from a clear sky. Finally, here's an amazing fact for you. Sometimes, in massive storm systems, lightning doesn't just go up or down. It can travel sideways for incredible distances. Scientists have a name for these giant flashes, megaflashes. The record holder for the longest megaflash traveled over 768 kilometers, or 477 miles, across 3 United States. That's like a single lightning flash, stretching from Dallas to Houston and beyond. These colossal flashes show just how much energy can be stored and released in our atmosphere. So stay curious, and keep watching the skies. From a safe place, of course.